Alright, people, so today we are going to talk about optimization. Optimization. It's a derivative of extrema, and I said pun intended. If you don't get that, just get out of here. Just joking. Every, as everybody gets up and walks out. The word derivative doesn't just have math implications. It means like a side note. You know what I mean? It means like a side conversation. And then no, but I mean a derivative of extrema. Okay. Pun intended. Because that's a pun. Anyways, guys, just looking at the word, what do you think is going to happen? What does optimize mean? Say that again. It's the best of, right? You're looking for the best answer. And I say it's a derivative of extrema. Extrema means what? Max and min. So think about, we're going to be finding the best possible max versus the best possible min. So here is why most people kind of get confused. These are real world problems. So it's like the related rates of the first derivative test, okay? So these are all real world situations, okay? These are all real world situations, and we're trying to optimize. This is actually, it's real world, so it's actually most applicable in the real world. In finance, in construction, in anything. Guys, you don't just blindly do stuff. You figure it out. You figure out the best. If you were an inventor or a seller of a product, let's say Apple, right? Let's say you're Apple. You just blindly make iPhone 7s? No. You optimize, meaning you figure out this is how many I need to make the most money. Does that make sense? Right? Most money, least cost. So that's what we're kind of talking about today. So, got some reading for you. Relax. So the following problems are maximum minimum optimization problems. They illustrate one of the most important applications of the first derivative. Okay? Many students find these problems intimidating because they're essentially word problems, and they do not appear to have there does not appear to be a pattern to these problems. However, if you are patient, you can minimize your anxiety and maximize your success with these problems by the following guidelines. This is what you need to write down. Step 1. Read each problem slowly and carefully. Step 2. If appropriate, draw a sketch or diagram of the problem. Step 3. Define the variables to be used and carefully label your picture or diagram with these problems. The most important step here. Write down the equations which are related to your problem or diagram. I will not be giving you the equations. You will have to figure them out for yourselves. Okay? Clearly denote the equation which you are asked to minimize or maximize. Figure out what are you trying to do. Okay? Experience will show that most optimization problems will begin with two equations. One equation is a constraint equation. The other is an optimization equation. The constraint equation is used to solve for one of the variables. This is then substituted into the optimization equation before differentiation occurs. Some problems may have no constraint equation. Some problems may have two or more. And then the last step, basically, is before differentiating, make sure the optimization equation is only in one variable. Then differentiate using your rules. Okay, I'll give you some time to copy those steps. Stop. All right, here we go. So once again, these 6 steps, they really only boil down to about 3 parts. Okay, so read the question carefully, obviously. Draw a sketch if you can. Sometimes it's easier to not draw a sketch because your sketch is probably more confusing than the actual problem. Define the variables. Obviously, sometimes we're going to use x's and y's. Sometimes we're going to use r's and h's because we're depending on what you're dealing with. Okay, don't be creative. Okay, that's what I'm going to say is don't use a b because that's your favorite letter. Okay, because sometimes it gets confusing. The biggest one is number 4 and 5. Okay, when you write down your equations, clearly understand which one you're trying to max or minimize versus which one is your constraint. Does everybody understand what a constraint is, right? Constraint just means that's my restriction. Like if I'm telling you, hey, like you're going to see in the next problem, we're going to be building a fence, but we have a constraint of the amount of material we're going to use. You know what I mean? So like it's that kind of stuff. And then of course, we are differentiating, and since it's max and min, we're only doing which derivative? First derivative, okay? And then we can tell what's going to happen, okay? All right, let's try it. Let's try the first one. Here we go. Example 1. We need to enclose a field with a fence, okay? So we're ranchers today. Ranchers use calculus. We have 500 feet of fencing material, and a building is on one side of the field, so we won't need any fencing. Determine the dimensions of that field, of the field that will enclose the largest area. Okay? So, you guys need to understand. Tell me what we have here. 500 feet of fencing. We have a building on one side. On that side. So, can y'all give me a sketch? I mean, I don't have to draw a house. I'm just going to say, look, here's my building. There's my building. Right? And then let's draw a rectangle and say, here's my fencing. Does everybody understand that that's what's going on? So you see I only need 3 sides. Agreed? Let's label these sides. What do you want to label them? X's and Y's? Sure. Which one do you think is going to be which? They don't tell you. So they don't tell you that it's a rectangle, right? But you have a field, and those fields are what shape? Okay? So here's the thing. It can't be a circle because then there's no sides to a circle. You know what I'm saying? It could be, I guess, a triangle, but it'd be a pretty weird big triangle. Okay? Let's label. What do you want to label this? Which one? Why is that a good idea? X goes horizontal. So what do you want to call this? Y. And what do you want to call this? No. They're the same length. Aren't they? They're the same? So call them both Y. Okay? So, everybody go with my sketch? Understand what's going on now? Okay. What am I trying to do? I need the largest area. So I'm trying to get the max area. Does everybody agree with that? So I'm trying to maximize what? Area. And in this case, how would I find area? Guys, what shape is this? How do you find area of just length times width? X times Y. Alrighty. Are we okay? It's Monday, right? Oh, then there's no excuse. Okay. It's your Monday. Alright, what is my constraint, people? What is my constraint? What is my limit here? I have a limit of what? Of fencing. I have a limit of fencing. 500 feet. So my perimeter, but except notice it wouldn't go all the way around because remember, I'm not using fencing here. Does everybody got that? Does everybody agree that 2y plus x has to be equal to 500? Does everybody understand that that is my constraint? We good? Okay, so that's literally our first 3 steps right there. Okay? So now, here's what we got to do. I want to derive, but I don't want to derive. Notice that each one of them has 2 variables, right? So what I'm going to do is I'm going to relate my equations so that I can substitute into my, I'm going to say max slash min, because depending on what I'm trying to find, max slash min equation, so it will have only one variable. Kindly. So basically, I'm telling you this, guys. Take your, by the way, which one is like my main equation? Which one am I trying to maximize? This one, right? So I'm going to go to my constraint and try and relate it, which means what? Solve for x or y. It does not matter. It's truly up to you. It is your decision. Okay? It is your decision to solve for one of these so that I can go back and plug it into the area one and I'll only have one variable. Does that make sense? Okay? So this is kind of like your Algebra 2 systems, right? In this step. So, I will let you choose. Do I want to solve for x or do I want to solve for y? Very good. So notice, if I want to get x by itself, all I'm going to do is move the 2y. Good? If I want to get y by itself, what am I going to have to do? Move the x and then divide everything by 2. It'll still work, just more steps. Does everybody see that? Sometimes there's not going to be an easy one. Sometimes either one's going to be, doesn't matter, just choose one. You know what I'm saying? So in this case, does everybody agree that x is equal to 500 minus 2y? Right? X equals to 500 minus 2y. So therefore, area is really 500 minus 2y times y. Agreed? Area is really 500y minus 2y squared. This is my y. So x was 500 minus 2y, y is still y. Right? Does everybody understand where I got the 500y minus 2y squared? Okay, so then this is my area. This is really my area equation. Now let's maximize that. In order for me to maximize or find a maximum in, what do I have to do? Take the derivative. Okay? So what is, in this case, a prime? And what do I do to find a maximum in? Set it equal to 0. So does everybody agree that 500 is going to be equal to 4y? That y will be equal to? $125. So here's what I need you to do though. So this is my critical point essentially. Agreed with that? So how do I know that it's my max? How do I know that it's a max? What can I do? I can test, right? At this point, so I got my number, I got my y, right? I have my y, but I just want to make sure that it's my max y, because what if it's my minimum? You see what I'm saying? So very simple, easy. Just test 125 from which equation? The derivative. So this one, right? So 500 minus 4y, and then test anything to the left and anything to the right. So you can test, sure, 100. If you test 100, what do you get? So positive. If you test, let's say what, 130? Negative. What happens? Does everybody agree that this is my max then? So this was just a verification. You good with that? So does everybody agree this is my max y? Right? Right? So the question was determine the dimensions. For dimensions, you need what? You need the sides. So I know the y. Can I get the x? How? X is 500 minus 2y. So if x is equal to 500 minus 2y, then x is 500 minus 2 times 125. Therefore, x is what? 250. We good with that? You could just, since you labeled it like that, you could just say the dimensions of, because it's a rectangle, of 125 and 250. We good with that? So then finally, I do want you to double check something at this point. Does this satisfy my constraint? Remember my constraint of only having 500 feet of fencing? So does 2 times 125 plus 250, does that equal to 500? Yes, it does. 125 times 2 is 250. 250 plus 250 is 500. So this satisfies my constraint. So therefore, the question was, determine the dimensions of the field that will enclose the largest area. Good. The dimensions of the field will be what? will be 250 feet, was it feet? By 125 feet. And then you could say this is x, this is y, just to kind of double. Because does it actually matter? Yes. Because there's two of the y's and only one of the x's, right? So, does everybody see what we're doing here? Okay. So we're basically just doing the first derivative, right? We're finding max and min. Okay. So that doesn't change. That doesn't change. You're still going to take the first derivative, find the critical point, make sure it's your max or min depending on what you're trying to do. Okay? Where is this going to get difficult? Tell me. No, I don't. We normally don't go into trig. Can we? I'm sure we can. I don't think I do that to you. Yes, I'm evil. Okay. So, where else do you suppose this might get difficult? I think actually I think your biggest problem is going to be understanding the problem itself. Like pulling out, not to be rude or anything, but you guys really are not good at pulling out information. Okay? You have this like weird idea and it's like you draw a box that's shaped like a rectangular prism or like a triangle and I'm like, why would you, what kind of box does that? You know what I mean? Like most of the time. Yes, let's just blame your English teachers that you're not good at calculus, right? All right, we good? Okay. So let's try another example. Let's try another example. This one I would say is more complex. Okay. So we went from easy to expert mode right here. Okay. So here we go. We want to construct a box. We're constructing a box whose base length is 3 times the base width. The material used to build the top and the bottom costs $10 per square foot. And the material used for the sides costs $6 per square foot. If the box must have a volume of 50 cubic feet, determine the dimensions that will minimize the cost to build the box. I'll give you time to copy. All right, what do we got going on here? What do we got going on here? It's a what? It's not a cube. Because cubes, there's a difference. Cubes are all the same size. And they're different. So it's a box, a rectangular box. Doesn't have to be perfect. Okay? Alright, so tell me what I know about this box. Okay, let's label my box though. Let's label it. Give it some fancy, some. How about height? Since they mentioned width and length, right? How about W? And then how about L? I do know something interesting about my L though, my length. It's 3W. Agreed with that? That I have a length, a width, and a height, and I know that my length, however, is 3W. So I'm kind of, does everybody see how I'm kind of getting fancy already? And I know that these are related somehow, right? We good? Can y'all give me my constraint? $50. So I have to have a volume of 50. Agreed? So does everybody agree that 50 has to equal, how do you find volume of a box like this? Length times width times height. Agreed? That 50 has to equal to length times width times height. Actually, I can go a step further. Since I know my length is really what? 3W. Couldn't I give my equation 3W squared H? Right? Since L is 3W, so it'd be 3W squared H. We good with that? Alright. So I know my constraint is 50 equals 3W squared H. We good? What am I trying to do? Minimize cost. So I'm trying to minimize cost. What's my equation for cost? So this is where it's going to be tricky.
Oh,
So what do they tell me about my costs? It's $10 per square foot. So when we talk about square foot, we're talking about what? Area. So we're talking about $10 for the area of the top and bottom. Right? First of all, does everybody see they're going to be the same? So $10 for what? 3W. How would you find the area of the bottom? 3W times W, which is 3W squared. Agreed? And I'm going to say there's going to be two 3W squareds. Okay? I know that I could write that as 6, but I just wanted to let you know that I have two, one bottom, one top. Agreed? We good? Everybody with me? Okay? Plus, and then it tells me that it's, bless you, it's going to be $6 for the sides. Right? It's going to be $6 for the sides. So $6 for, let's do this front side, looking at me. What's gonna be the, first of all, are they all the same size? No. I have 2 in the front and 2 on the sides. You see the difference? So let's look at this front one. What are the dimensions? How would you find the area of that one? 3WH. Agreed? How many of those are there? So 2 3WHs plus 2, what about the sides? WH. Okay? So, I'm going to simplify this, but I wrote it out the long way because I want you to understand all the bits and pieces we got going on. Okay? So, does everybody see that it's $10 for my 2 top and bottoms? The area of those would be 3W squared. Good? And then it's $6 for my 2 front and back sides, which would be 3WH, and then plus the 2 sides, which would be 2WH, right? Let's simplify this. 2 times 3, of course, is times 10. So I got 60W squared, right? And then can I simplify this one? It would be 2 times 3, of course, is 6WH plus 2WH, which is 8WH, times 6 plus 48WH. Good? Are we good? So this is actually my cost function. Okay, in the end, that's my cost. Does everybody see how I built it, though, right? I looked at every piece. All right, so then now what do you think I got to do? Nope. I got to relate them somehow. I have 2 equations. 53W squared H, and then C. Which one am I trying to maximize? Or minimize, in this case? The C. So I need to get this in a same variable over here. Look at it. What's going to be the easiest one to solve for? The H. Why not W? Has a square, so I'm going to have to square root. Do I want to do that? Probably not. Can I? Yes, I don't want to. So, let's relate 50 equals 3W squared H, and I want to solve for H. This is actually very simple. $50 divided by 3W squared. Are we good with that? We good? Okay. So then now what? See how it's going to go here? So here's what we have. We have C equals 60W squared plus 48W times 50 3W squared. Can I simplify this? So over here, can I simplify it? Notice that a W and a W, what's going to happen? One of them is going to cancel. And then a 3 and a 48, 16. So does everybody see what I have going on here? I have 60W squared, 16 times 50. $800 over W. Everybody good? Good? Now what? Now derive. So what is my C prime? 120W. 120W. And then, ooh, how do I derive that? So think of this. You can do the quotient if you want to do the long way. Remember, we can think of this as 800W to the negative 1 power. Remember doing that? Right? So what's going to happen? Negative 800. And then it would become W to the negative 2. But then it's just, that means it's W squared on the bottom. Y'all with me on that one? So, negative 1 times 800 is the negative 800. And then I would subtract 1, which would be negative 2. But then move it back to the bottom, make it positive by moving it back to the bottom. You with me? Okay, so that is my derivative. That is my derivative. I can actually simplify this even more because what's the problem here? What are they trying to... No. What are they trying to do? Subtract. And in order for me to subtract fractions, what do they have to have? So then, do they have that at this point? No. But it's very simple. This is W squared, and what is this one missing? W squared. So good. I can fix this and say it's 120 W cubed minus 800. All of that over W squared. Ever see what I did? Right? And then now, if this is equal to 0, this is equal to 0. Okay? I'm kind of running out of room on my board. You're going to just have to go to another sheet of paper. So here's what I have. I have 120W cubed minus 800 over W squared equals to 0. Now, how do I solve things like this? How do I set these equal to 0? Because this one didn't have a W squared, right? So I give a W squared to both top and bottom so they can have common denominators. But when I multiply this by W squared, it becomes cubed. Yeah, it has 1, so it becomes 3. So guys, how do I solve things like this? It's just the top, technically. However, it can't be 0. Does everybody understand that? Why? Good. So we need to say that. We need to say that. W equals 0 is undefined, meaning it can never be 0, which, guys, it kind of makes sense. It kind of makes sense. Yes, ma'am? No. So it kind of makes sense because, remember, this is a real-world problem. We're building a box. Can I build a box that has a width of 0? No. It wouldn't be a box if I tried that. Does that make sense? So this is where the math agrees with the real world, guys. So W is 0 is undefined. So it's there for us mathematically, but it just makes sense in the real world to say, well, obviously I can't have a box with no width, right? So now, really, let's pay attention to the top. 120 cubed minus 800 equals to 0. What do you got? What do I do? So 120W cubed is 800, right? So W cubed is 800 over 120. W is what? The cubed root of 800 over 120. And then, guys, you could actually just give, because I need to know what this W is. By the way, is it a plus or minus in this case? Okay, length can't be negative, but you know how like when I take a square root I get 2 answers? Is that the case here? It's an odd. Anytime it's odd, it's just whatever it is. Okay? It's only even only when you're doing like a square root, 4th root, 6th root, if you ever have to do those. But that's when you'll get positive, negative. Got it? So in this case, guys, can you tell me what is the cubed root of 800 divided by 120? Does everybody know how to do cubed root in a calculator? No. So if you go to math, see number 4. So number 4 is cubed root, and what do you think number 5 is, by the way? You can put anything, but you have to put the number first, so it's weird. You have to put like 6th root, so you're going to put 6 and then go to math number 5, and it'll make it 6th root. So you're going to do the 4th root of, or the 3rd root of 800 over 120. 1 point what? Let's give me 3 decimals. 882. So this is my width. This is my width. Okay? This is my width. What should I at this point at least try and figure out and verify? That this is my what? Is it a max? What? It's a min, right? I'm trying to minimize. So let's double check that. So 1.882, and where am I going to double check that in? Which is here, right? So go test this. 120w cubed minus 800 over w squared equals 0. Oh, no, not equals 0. You don't have to put that. So 120w cubed minus 800 over w squared. And then give me a good number to test to the left. We just said 0 is undefined. So 1. Could I do negative 1? Why not? Can't have a negative width anyway, so why test it? You see what I'm saying? So let's try 1. What do you got? Negative. And then let's try 2. What do you got? What happened? It's a min. Verified. We're good to go? So that at this point, this is my minimum width. Well, how am I going to find the rest? We already know that height is equal to 50 over 3w squared, so find me the height. Four point what? We'll say 4.706. Okay? And then what about my length? My length is 3w, so therefore my length is 3 times 1.882. Therefore my length is what? 5.646. Okay? So the dimensions of the box with minimum cost would be, how would I write this? It's always length with height. Length with height. Does it technically matter? Not at all. Okay, but just formality. So it would be 5.646 by the way, what is this? Feet? Inches, does it say? Feet? By 1.882 feet by 4.706 feet. And if you want to, that's length with height. We good? Okay. So it's just dimensions of a box with minimum cost would be, and then I just put my length, width, and height. Okay. So guys, I can stand up here and just do a bunch of examples for you, but it's not going to help you. You just have to get in there and grind, right? You're just going to have to get in there and grind. So that's what we're going to do right now. We're going to give you examples. This is what you're going to